All right, on section 5.2, what we're going to be looking at is we're going to be looking at solving a system of equations with several variables. Meaning, in the first section we talked about just x and y. This is going to have an x, y, z in this case, so it's going to be a kind of a triangular form or three-dimensional type thing that we're going to be looking at. So on something like this, it's going to have x minus 2y minus 2z, or 1z, sorry, equals 1. Y plus 2z equals 5. And if it gives me z equals 3, how do you solve that? Well, first of all, once you have one like this, then you can actually work backwards to find another one. So a lot of this is going to be very similar to if you watch section 5.1, it's going to be more of a elimination or substitution than graphing, mainly because I'm not aware of how the TI would end up graphing three-dimensional. But anyway, all I'm doing is I'm just plugging back numbers to see what's end up happening or to find my actual answers. So all I'm doing is I'm just replacing. Like I said, it's a whole lot of substitution. Just make sure you're very, very careful with signs. I know in a lot of cases I have a lot of students that end up getting their signs wrong. So there's the three answers. A lot of times they're written like this, X, Y, Z, or as known as an ordered triple, because you're doing three numbers. Okay, so just to give you another kind of type here where you actually have to do a lot of solving. These things here, they can be solved a couple different ways, but realistically I like to use a lot of elimination when we're doing this. I think in the long run it pays off to do it that way. I would be really careful with trying to do substitution, but like I said, there are other ways of doing it. So the first thing that I like to do is, if I look at all three, is I'm just going to take and just look at the first two and decide which letter would I like to get rid of. I'm going to get rid of the y's in this problem because if you look at it, the y's are already set up to be, if I add straight down like elimination, they're going to go away. So if I add those together, 1x plus 1x gives me 2x. The y's cancel out. 3z minus 1z is 2z. And 1 plus 13 is 14. Now I'm going to let that simmer in the back burner, and now I'm going to do the first and the third. Now, I was always taught to do first and second, then first and third. However, it shouldn't matter what order you do them in. If you do first and second, second and third, or first and third, second and third, it isn't going to matter, because who's to say what's the first equation? So I just like to go first and second, then first and third. I'm reusing the first equation. Whether you reuse the second one or the third one, that's your choice. But if I do that there again, I don't have to get rid of anything. I don't have to multiply by anything. I'm just going to add 1x plus 3x is 4x. Y's cancel out. Minus 2z equals 4. Then from here, I do the same thing over again. I look at elimination, and I look at it and go, oh, the z's can cancel out. So if I add straight down, I end up with 6x equals 18. I divide by 6, and I get x equals 3. So as soon as you have one, now you work backwards to find the other two. So all I'm going to do is I'm going to put the 3 in for this one here. So 2 times 3 plus 2z equals 14. Now, just so that you guys know, it's important for you guys to know that it doesn't matter what one you plug it back into. It will give you the same answer regardless. I just like to stay as positive as I can, so therefore that's how I like to go about doing it. It's totally up to you though. If you subtract 6 to both sides and divide by 2, you get z equals 4. So now that I have two of them, now let's go back to one of the originals and let's find the y's guy. I'm going to use the middle one in this case. I don't want to use the top one because I had a negative 2 in front of it. I'm going to use the middle one. So I've got 3 plus 2y minus 4 equals 13. 3 minus 4 is negative 1. add 1 to both sides, I get 2y equals 14. Divide by 2 and I get y equals 7. So, and realistically that's how all of them are going to happen. There very well could be a system where you have no solution, where all the letters cancel and you're left with 0 equals like 10. That's not possible. Or you could very well find out to be 0 equals 0, which is again an all real number situation. But realistically, it's a lot of substitution and a lot of working backwards to find the answers. Okay. If they ever give you one that has like what I consider a hole in it, where they're missing one of the letters, so for example, something like this, if it's got x minus 4z equals 1, 2x minus y minus 6z equals 4, 2x plus 3y minus 2z equals 8, then where I would start is I would start right here. And the letter I would get rid of is I would get rid of the y's. The reason for that is because if I do that where I get rid of the y's, then I can just use that with this equation because I have an x and a z already. It's basically getting rid of one of the steps for you. So just to show you what happens there, if I multiply all this by 3, I get 6x minus 3y minus 18z equals 12. Go straight down, I get 8x. Y's cancel. Minus 20z equals 20. Now I can use this equation and this equation because they both have an x, or they both have x and z, and then I can get rid of it. And so if I multiply the top one by negative 5, I get negative 5x plus 20z minus 5. I get 3x equals 15. Divide by 3. X equals 5. Then once I have that, I work backwards. I just keep back plugging them in until I get the other 3. So, just so that you're aware of it, this is very similar to the elimination method that we learned in section 1. We're not going to do anything different. Just got to plug it in twice. I kind of like to consider it the Glade technique, where you got to plug it in, like the commercial. So anyway, I will see you later. Bye.